Okay guys, we're going to pick up with lesson 3-1 that we started last week. Remember, we've already filled in this first portion of the notes, and we're going to pick up down here at the bottom of the first page with a couple of vocabulary words that will help you with this lesson. Our learning target for this lesson is going to be that you will be able to determine the x and y intercepts of a linear equation, and then you'll be able to graph an equation by using the intercepts and by making a table. So let's start by talking about what the intercepts are. The x-intercept is where your graph is going to cross the x-axis on the coordinate plane. And then the y-intercept is going to be where that graph crosses the y-axis. So notice the ordered pairs. Your x-intercept is always going to have a y of 0. That's because in order to be on the x-axis, it has to have a y of 0. That's where the x-axis is. And also, the y-intercept is always going to have an x of 0. That's because for a point to be on the y-axis, it must have an x of 0. So keep that in mind as we look on the next page and look at the graph. Turn over and let's take a look at this graph. Now, all we want to do on this graph is have you identify the x-intercept and the y-intercept. So remember, we're looking for the points at which the graph crosses the different axes. So our x-intercept is going to be right here at x equal to 2. So you can write that as just x equal to 2, or you can write it as the ordered pair, which would be 2, 0. Remember, an x-intercept is always going to have a y of 0. If we wanted to identify the y-intercept on this graph, we look on the y-axis and see where the line crosses, and it crosses at y is equal to 5. Or if we want to write it as an ordered pair, x of 0, y of 5. Either one of those is acceptable. So you can see how this gives us an easy way to graph, a lot quicker than making a table, let's say. Okay, so now with example 3, let's talk about how we would work a word problem, and then we're actually going to come back and look at a couple of more graphs. Example 3, you kind of need to get a feel for what's going on in the problem. You've got a box of peanuts that's being poured into a bag at a rate of 4 ounces per second. So the table shows you the function that relates the weight of the peanuts in the box and the time in seconds that the peanuts have been poured into the bag. So you can see as the time goes by, less peanuts are left in the box because they're being poured out into the bag. Does that make sense? Let me say that again. When the time starts here at 0 seconds, it's going up by 125 seconds. Here's the ounces that are left in the box. The weight of the peanuts is decreasing as they're being poured out over time. So the way we can find our x and y intercepts is we look for the zeros in our table. We can see that when x is 0, that's going to be our y-intercept, and when y is 0, that's going to be our x-intercept. So the x-intercept would be the point 500, 0. And the y-intercept would be 0, 2000. And if we had a graph and we were going to graph this function, we could put those 2 points on the graph and draw our line, and that would be our graph. We would not have to go to the trouble of making a table or using the points in the table. Now, let's talk about what these points represent. The point 500, 0 means that after 500 seconds have passed, there were 0 peanuts left in the box, 0 ounces. So therefore, it took 500 seconds to pour all of the peanuts from the box into the bag. So you really just use the labels on your table in order to tell what the interpretation of the point is going to be. When we look at our y-intercept, that would be the point 0, 2000. And again, if we use our label, x stands for how much time has passed. So that means 0 seconds have passed. That's before anything was done at the beginning. And you can see that at that point, there were 2,000 ounces of peanuts in the box. So that means that they started with 2,000 ounces of peanuts in the box. Because at 0 seconds, none had been poured out yet. So use the labels on your table to help you do the interpretation. Okay, let's take a look at the last page of notes. This is example 4 and 5, and what we're going to use in both of these examples is a different way to graph a linear equation. Remember, our goal in this lesson was to be able to graph an equation, and we have done that already by making a table. Now we're going to look at how to use the intercepts, and then we'll come back in example 5 and review making a table one last time. So here's a linear equation. We know it's linear by looking at it because it meets the conditions that we learned earlier in this lesson. There is no x and y in one term, there are no variables with exponents, and there are no variables in the denominator of a fraction. So we know it's linear. So now we're going to use the intercepts to graph it. So it says right here, here's your little reminder, to find the x-intercept we plug in 0 for y. Because remember, we learned just a second ago that if it's an x-intercept, it's going to have a y of 0. Also, to find the y-intercept, you plug in the 0 for x, because we learned that if it's a y-intercept, the x is always going to be 0. So it's kind of the opposite. If you're looking for the y-intercept, you plug in 0 for x. If you're looking for the x-intercept, you plug in 0 for y. So over here to the side, I'm going to show my work. If I'm solving for the x-intercept, then I'm going to put in 0 for y. So I'm going to write the equation substituting 0 for y. Then I'm just going to solve for x. And I find that x equals 1. So my x-intercept is going to be the point 1, 0. Now for the y-intercept, I'm going to plug in 0 for x. So 4 times 0 minus y equals 4. I'm still going to just solve for x here. Negative y equals 4. If I divide by negative 1, y equals negative 4. So that would be the point 0, negative 4. Now watch how easy this is to graph. I'm going to come over here and I'm going to plot a point at 1, 0. That's my x-intercept. And at 0, negative 4, that's my y-intercept. And all I have to do is draw my straight line right through those 2 points, and I've graphed that equation. This is probably the quickest way that we've learned so far to graph a linear equation. Okay, let's take a look at example 5. This time we're going to make a table. So we're going to take our equation. Again, we know it's linear because x and y are not in the same term. There's no variables with exponents and no variables in the denominator of a fraction. So I'm going to graph this line by making a table. So the way I like to set my table up is my x input. Now look, I put a little reminder here because you guys always get stuck about how you start. You get to choose the values for x. That's your input. So you can choose any value for x and it will work. Here's my function, my equation. Here's going to be my y output, and then I'm going to form my ordered pair by using my input and my output. Okay, so that's a good way to set up a table. Now, I always like to choose some negative numbers as well as some positive numbers, just so my graph goes across the coordinate plane. So when I put in my x inputs, you can see negative 4 plus 2 is negative 2. So my first point that I'm going to plot is negative 2, 2. No, -2, -2. And I like to plot my points as I go because I can tell if they're not lining up that I probably made a mathematical error in my table, and I can go back and check it real quick. So when I put in -1, then I get -2 plus 2, which is 0. So my second point is -1, 0. -1, 0. And then for 0 and 2, so far we're lining up nicely. And then my last one, I usually do 4, is going to be 2 plus 2, which is 4. So 1, 4, 1, and 4. Good. And then all you have to do is connect your dots to make your line. And you've now graphed that linear equation by making a table. Okay? So let's recap what we've done. We started out with lesson 3-1, and we learned about standard form. You've got these notes filled in on your paper. We learned about telling if it's linear and what it means to be in standard form. We did these 4 examples. Just to recap, you can tell that these are all going to be linear except B, which has the xy in one term, and D, which has the exponent. So A and C are linear, and we can put those in standard form. Then we moved on to graphing. We learned today that the x and y intercept are 2 points we can use to graph. We learned how to find them. We knew that the x is always going to have a y of 0, and the y-intercept is always going to have an x of 0. We identified them on this graph. Then we learned how to set up a word problem and know how to identify the x and y intercept from a table and looking for those zeros again. We also talked about interpreting those points, giving meaning to those points. And then the last 2 things that we just did was learning how to graph using intercepts and by making a table. For your test, you'll be responsible for showing that you know both ways, but there'll be a portion of the test where you get to choose the way that you like to do it. So it's always good to have a choice there. But I think you'll find the intercepts are a little bit faster when they come out to be a whole number. That makes it a lot easier. But anyway, we will continue this when you come back. I hope you guys had a great time at the choir field trip, and I hope that this video helped you stay caught up with us in class.